Hello students, welcome to my lecture on computer graphics. I am Shravani Kundu, Assistant Professor, Department of Computer Science and Engineering, Guru Nanak Institute of Technology. Today I will discuss Cohen-Sutherland line clipping algorithm. After learning this lecture, after going through it, you will be able to clip the lines with respect to the clip window. So this is the basic objective and the corresponding outcome for this lecture. Now, here we will discuss the line clipping algorithm. And the basic objective of the line clipping algorithm is to cut the line segment with respect to some window which is called the clip window. So here you can see the window which is drawn by the red color. That window, some lines are present inside that window, some lines are present outside of the window, and some lines intersect that window. So what is the task we have to perform? With respect to this window, whatever the line segment is present inside that window, we will consider that one, and the rest of the line segments or lines will be discarded. And that is the basic operation of the clipping. That means we have to cut, we have to select a particular region, and whatever the object will come inside that region, we have to keep those objects, and other object which is outside of that region will be discarded. Okay, so here we will discuss the Cohen-Sutherland line clipping algorithm. So we will discuss Cohen-Sutherland line clipping algorithm. This Cohen-Sutherland line clipping algorithm, it is a very basic algorithm, and the interesting features of this algorithm is that it will not process with all the lines. In the initial checking step, so there is an initial step. In that initial step, it will check which line segment does not belong inside the clip window. That means it will identify those line segments which are not at all present or intersected with respect to the clip window, and those identified line segment which is totally outside of the clip window, those line segment will be discarded. That means this algorithm will not deal with all the algorithm. At the beginning phase, it will just identify by using a simple logic, and using that logic it will discard those lines, and then it deals with all the lines which are present, which is inside the clip window, and those line segments which is intersected by the clip window. So first of all, we will see how this Cohen-Sutherland line clipping algorithm is able to discard all the lines which is not present inside the clip window. Okay, so this task can be performed with the help of a technique that is called the region code. So which is called the region code. Okay, so this region code basically identify whether the line segment is above the clip window or below or left side or the right side of the clip window. So here you can see this is inside with respect to this clip window, the line segments are divided into some present in some region. So you can see those dotted lines are there, which are the extended line of the boundary line of the clip window, and based on the extended boundary line of the clip window, those regions are divided into some sub-regions. Okay, so you can observe there are in total 9 regions are there. So for each regions, we will generate some region code. And what is the logic to generate the region code? So you remember that region code will be the 4-bit region code. So this is a 4-bit region code. Fine. And the region codes, the bits are identified like that. So this is identified that L, R, B and A. That is ABRL. What is ABRL stands for? The A stands for above. The B stands for below. R stands for right. And L stands for left. Okay. So that means if a region belongs to the left side of the clip window, then that for that particular region, the L bit will be set to 1, otherwise 0. So each bit consists either 0 or 1. So any two of them. So while when it will be 1, if the condition is satisfied, or otherwise it will be 0. So we consider first this one. Okay, this is region, this segment. So here you can see that this particular region is above the clip window and on the left side of the clip window. So this region is above the clip window. So this is my clip window and this is the above the clip window, this particular region, and it belongs to the left side of the clip window. So if so, that means the L bit will be 1 and the A bit will be 1 and the rest of the 2 will 0 because it is not below, it is not right. So what will be the region code? The region code will be 1001. Now consider this one. So this region is only the above of the clip window. It is not in the left side, not in the right side. Fine. So for this particular region, so the region code will be 1000. Now for this particular segment, the region code will be, it is in the right side and above. So the above bit will be 1, below bit will be 0, right will be 1, left will be 0. Again, it is this particular segment is only the right side. That means this region is the right side of the clip window. So this above will be 0, below will be 0, right will be 1 and left will be 0. Consider this one. This is below right. So if it is below right, that means A bit will be 0, B and R bit will be 1 and L bit will be 0. Again, for this particular section, it is only the below. So A is 0, below bit will be 1, left and right both will be 0. Okay. For this particular segment, this region, it is left side and below. Okay. So this region belongs to the left and below side of the clip window. So L and B bit will be 1 and rest of the bits will be 0. So it will be 0, 1, 0, 1. Okay. And last one, this particular region, so this is only belongs to the left side of the clip window. So this for this particular region, the region code will be 0, 0, 0, 1. And the region code for the inside the clip window will be 0, 0, 0, 0 because it is not left, not right, not below, not above. So for the region code for the clip window will be 0, 0. So in this way, we can put some region code for all the 9 regions. Now, how this Cohen-Sutherland line clipping algorithm first eliminate all the lines which is not, that means all lines which is not inside the clip window or not intersected by the clip window. That means those lines which are not at all comes under the clipping algorithm. So those lines will be discarded. How we can see it now? So before that, we will put some name of the line segment. So we put, let us say this line segment is P1, this is P2, this is P3, P4, P5, P6, P7, P8, P9 and P10. So there are total 5 line segments, and you can see that P1, P2, P9, P10 and P6, P5, P6. So those 3 line segments will be initially discarded because they will not come under the clipping window. Fine. So how we will check it? So we will consider the first line segment. That means we will consider the line segment P1 and P2. Okay. We will consider the line segment P1 and P2. Consider this one. So what we have to do, we have to find out the region code for P1. So what is the region code for the P1? The region code for the P1, see P1 belongs to this region. So the region code for the P1 is 1000. And what is the region code for P2? The region code for P2 is 1010. After finding the region code between P1 and for both the point P1 and P2, you perform the AND operation between these two region code. That means you have to perform P1 and P2 operation. So if you perform the ANDing operation between these two, you will definitely get the output this one. And you can see this output of the AND operation is not equals to 0. Okay. So what we will do over here, Cohen-Sutherland line clipping algorithm says that find out the region code for both the points of the line segment. Perform the AND operation. After performing the AND operation, if the output is not equals to 0, that means output is something else, then that line segment is totally outside of the region. Okay. So what happened over here? So here you can see that in this case, this is not equals to 0. So we will totally discard this line segment. P9 and P10. Okay. So next we will consider the line segment P9 and P10. So definitely you will find out the region code for P9 and the region code for P10. Okay. So region code for P9 is 1001, as you can see over here, and region code for P10 is 0001. Either, as I told you earlier, either you can perform AND operation or you can check the similarity of one bit, similarity of bit, that means similarity of position, whether two bits are same one value or not. If it is so, then it is outside. So I am doing just AND operation, ANDing operation, P9 and P10. So if you perform this ANDing operation, you can see the output will be 0001. So which is again not equals to 0. So that means this line segment is totally outside and we have to discard it. Now consider the line segment P5 and P6. So if you consider the line segment P5 and P6, I will show it here. So if you consider the line segment P5 and P6, okay. So this is P5 and P6. What is region code for P5? The region code for P5 is 0010. And what is the region code for P6? P6 is 0100. So here, if you perform the AND operation, or you can check for the similarity. So I am performing the AND operation. So if I perform the AND operation between P5 and P6, it is 0. So what I told you, if it is not equal to 0, you can directly discard that line. That means there is no chance of to be able to present the line segment inside the clip window. So here P5, P6 is equals to 0. That means there is some possibilities that the P5, P6 will be totally inside the 0, or some portion of the line segment is inside the 0. Now what we have to do? We have to observe the code for each region code for each point. Here the region code for P5 is 0100. That means not 00. If the region code is 0000, that means the point P5 is inside the region. So here this P5 is not inside the region, and P6 is also not inside the region. That means it may be that some portion of the line segment is inside the clip window. So what we have to do further, we have to find out. So here you can see that P5, the bit, which bit is 1? The R bit is 1. And for the P6, which bit is 1? This below bit is 1. Okay. So that means this line segment will be intersected by the right boundary edge of the clip window and the below boundary edge of the clip window. Again I am repeating, check it. These two bits are 1. So this bit is which position? This is R, right? And this bit is which position? This is B. And the output is, and after performing the AND operation, the output is equals to 0. That means there is a possibility that the line segment will be inside the clip window. And as both the points are not 00, the region code region codes for P5 and P6 are not 0, 0, that means P5, P6 is not totally inside. So what happened? We have to find out the intersection. That means some intersected portion is present inside, maybe present inside the clip window. So with which line we have to find out the intersection? You can see easily that this R bit is 1 and the below bit is 1. That means the line segment P5 and P6 is intersected with the right boundary and the below boundary of the clip window. Okay, so right boundary means this one and the below boundary will be this one. So what we have to do? We have to find out the intersection point with the line P5, P6 with this one and with this one. Okay, we have to find out the intersection point with this line segment and this line segment. So this is the line segment of the this is the line of the clip window, which is the below boundary line, and this is the right boundary line of the clip window. So we have to find out the intersection point. So let us say this intersection point is P5 dashed and this intersection point is P6 dashed. After finding the intersection points, what you can see again, you have to find out the region code. So for this particular point, the region code is again 0010, and for this particular point, the region code is 0110. So what we can see that the intersected point, okay, so for this intersected point, the line segment is not again it is not present inside the polygon. So what I am again repeating, first let us check what will be the region code for P5 dash and P6 dash. So you can see that this P5 dash is present over here and P6 dash is present over here. Okay, so what you have to do for P5 dash, the region code will be 0110. Okay, because this point is right side, again this point is below side because this is on the line. So this is right side and this is also below, on the below. So we can say this is 0110. Again P6, this point is on the boundary of the right boundary. So that's why the right R bit will be 1, and it is also below, that means the B bit will be 1. Try to understand why this P6 dashed will be same 0110, because this P6 below, where the position of the P6 is right boundary. That means it is on the right boundary. So the right R is 1 and it is below the boundary. So B is also 1. So RB both are 1. So that's why 1, 1. The same thing is true for P5 dash. It is on the below boundary. So B bit will be 1 and it is on the right side of the right boundary. So R bit will be 1. So B and R both will be 1. So P5, for P5 dash the region code will be 0110 and for P6 dash the region code will be 0110. Now if you perform the AND operation between these two, you will get the 0110. That means which is not equals to 0. So as it is not equals to 0, as I told you, according to the Cohen-Sutherland line clipping algorithm, if the ANDing operation is not equals to 0, that indicates the line segment is totally outside of the clip window. So here P5 dash and P6 dash is totally outside of the clip window. That means this line segment is not inside the clip window. Okay. So in this way, we can discover the 3 line segment. Now we will consider the next one. We will consider the line segment P3, P4. Okay. So we will consider the line segment P3, P4. So here you can see that for the P3 and P4 line segment, again we have to find out the region code for P3 and region code for P5. Okay. So P3 and P4, this is my line segment. And we have to find out the region code for P3. We have to find out the region code for P4. So, as you know, I'm again writing, it is left, right, below, and above. This is the position. So, P3 region code is what? 0010. P4 belongs to here. It is 0100. If you perform the AND operation between P3 and P4, perform ANDing operation between P3 and P4. If you perform the ANDing operation, so output will be 0. So as the output is 0, that means either P3, P4 is totally inside of the polygon, inside of the clip window, or P3, some portion of the line, that means some line segment of P3, P4 is inside the clip window. So now we check which one is true. So here you can see that for P3 the region code is not 000. That means P3 is outside of the clip window, and P4 again the region code for P4 is not 0000. That means P4 is also outside. If both the point of a line segment is outside of the clip window, that means there must be some intersection. Okay, so here we have to find out the intersection. Now with which line segment we have to find out the intersection? Again the same logic. You can see for the P3 this bit is 1. This bit is 1 means the R bit is 1. Okay, and for P4 this bit is 1. That means the below bit is 1. That means we have to find out the intersection with the right boundary line and the below boundary line. That means we have to find out the intersection of this line segment. So P3, P4 is one line segment, and we have to find out the intersection of P3, P4 with the below boundary line, and we also find out the intersection with the right boundary line of the clip window. Okay, so if you find out the intersection, you can find out it easily. So this is my intersected point. So let us say this is P3 double dash. You can find out that intersection. You know the equation of P3, P4. You know the equation of this line. You know the equation of this line. You can find out the intersection of this one. So P3, P4. So let us say this is P4 dashed, single dashed, double dashed, whatever. Let us make it single dashed. So it is P3 dashed and P4 dashed. Okay. So these two are the intersection point. Now find out the P3 dashed region code for P3 dashed. So what will be the region code for P3 dashed? So this point is on the right, on the boundary of the right boundary of the clip window. P3 belongs to the right boundary of the clip window. That means R bit will be 1. Okay. Now here in this case it is this particular line segment. So this line segment, so here we can say, so this is on the right boundary and this is on the left boundary of the line segment. So what we have to do, we have to find out the region code for P3 dashed. So the region code for the P3 dash is 0, 0, 1, 0. And the region code for P4 dashed is equals to 0, 1, 0, 0. Okay. So what you have to do now, you have to find out the AND operation, same as before. So once you will find out the AND operation, that after performing the AND operation between P3 and P4, you will get the output, that means P3 dashed and P4 dashed, you will get the output 0. So after performing the AND operation with the intersection points, it is 0, and as these 2 points belongs to the boundary line of the line segment of the clip window, that means the P3 dash and P4 dash is inside the clip window. So that is the intersected, or that is the clipped line which is present inside the clip window. So again I am repeating, this particular section is very important to take the decision. After finding the intersection point, you can see that here P3 is on the boundary. The point P3 is on the boundary of the clip window, P4 dash is also on the boundary. So on the boundary of the clip window means this point is inside the clip window. Okay, so on the boundary, so we have to basically check. So if you can remember whether a point is inside or outside, we are checking for the greater than equals. That means we are checking something like that. We are checking with the if you can remember that x mean less than equals to x. So we are going for the equality operation also. So the same thing is true over here. So P3 is on the boundary. That means it is satisfying the equality operation. On the boundary means this point is part of the clip window. P4 dash is on the boundary of the below line. That means the P4 dash is also the part of the clip window. So P3 dash and P4 dash, the line segment constructed by P3 dash and P4 dash is present inside the clip window. So this is my clipped line. So we can draw it by some another color, so it will be easy for you to understand. So this is my clipped line. Okay. Now we will go for the last one, that P8 and P7. So if you find out the region code for the P8 and P7, you can see that for the P8 the region code is 0000. That means all zeros. So P7 P8, this is my line segment. So if you find out the region code for P7, it is 0000, and for the P8 is also 0000. That means region code for both the endpoint is 0000. That means if it is all bits are 0, that indicate the point, both the points are totally inside the clip window. So as it is totally inside the clip window, we don't need to perform any intersection, that which indicate the line is already present in the clip window. So here, after performing the operation, all this operation, after checking whether a line is inside and outside, what we get? We finally get the line segment P8 P7, that P7 P8, this line segment is present, this one is present inside the clip window, and the P3 dash and P4 dash, this particular segment is present inside the clip window. So if we observe the output of this algorithm, so we can finally visualize that this will be our final output. So let me draw it over here. So this will be our final output. Okay, so you can see that after performing the clipping operation, we will get this one. So in this way, the Cohen-Sutherland line clipping algorithm can find out which line segment is inside of the clipping window and which line segment is outside of the clipping window. It is very simple. It's just check the region code. Based on the region code, if the region or ending operation of both the region code is not equals to 0, that means it is totally outside, and if it is equals to 0, that means there is a possibility to be inside. Then we will observe both the point. If the region codes are not 0000 for all the both the endpoint, that means intersection is there. If there is intersection, find out the intersection point. Find out the region code for both the intersection point. Intersection points means that point belongs to the clip window. Now, if after performing the ANDing operation between two region code of two intersection point, if the output is 0, that indicate the line segment belongs to the clip window. Okay, so in this way, the Cohen-Sutherland line clipping algorithm can clip the line with respect to some clip window. So lastly, I will show you the code algorithm, how to write down the algorithm for the Cohen-Sutherland line clipping algorithm. Okay, so we are writing the algorithm. So basically, you just remember there are 3 possible cases. First one is completely inside the given rectangle. Case 2 is completely outside of the rectangle. Case 3 is partially inside the window. So basically 3 cases. First case is completely outside. That is completely outside. Completely outside means if it is not equals to 0. Number 2, completely inside. Completely inside means equals to 0 and both region code is equals to 0, 0, 0, 0. Okay, and the third one is completely, that means there is some intersection is there. Okay, in partially inside, so we can tell it that partially inside. Partially inside means there must be some intersection. So in that case, if you perform the AND operation, you also get the output 0, but here the region code, that means region code for both endpoints. Okay, for partially inside, if you perform the AND operation between two region code, you will get the 0, but both region code and region code for both endpoint not equals to 0, 0, 0, 0. Okay, so in these two cases, for case 2 and case 3, if you perform the AND operation between region code of two endpoint, you will get the output 0, but then you have to observe whether the both endpoint region code for both the endpoint is 0, 0, 0, 0 or not. If it is 0, 0, 0, 0, that indicate that the light is totally inside. But if it is not equals to 0, 0, 0, 0, then it is outside. So just I make a mistake. It will be totally, for totally inside, the region codes will be equals to 0, not equals to 0. It will be equals to 0. So if both region code is equals to 0, that means it is inside. If it is not equals to 0, then there must be some intersection. Okay, so here we will write down the algorithm for this Cohen-Sutherland line clipping procedure. So step 1, so this is my algorithm. So step 1, what you have to do, find out the region code. Okay, find out region code for endpoints of the line segment. So for which line we want to perform the clipping operation, for that line we have to find out the region code for both the endpoints. Fine. Next, step 2. If both region code, that means both region code is 0, 0, 0, 0, then line is inside. Okay, if it is not true, else, that means if both region code is not 0, 0, then what we have to do? In that case, we have to perform the AND operation. So else perform AND operation. Okay, AND operation between two region code. Now here we have to go for the sub step after performing this one. So let us say this is 3.2. Just a minute, not it will be 3.1. it will be 3.1. So choose perform AND operation. Okay. If after performing the AND operation, if output is not equals to 0, 0, 0, 0, what is the decision? Line is outside and exit. I have to stop the algorithm. Okay. Otherwise, else, if the output is not equals to 0, 0, that means if the ending operation generates some 0 output, so not equals to 0, 0 means any output. So if ending operation provides a 0 output, so in that case, what we have to do? We have to find out the intersection. So what we can write? We can write find intersection of line with boundary line of clip window. Okay, find the intersection points. Now, after finding the intersection points of the boundary clip window, boundary of the clip window, what you have to do? You have to again go for the sub point. So let us write it 3.2.1. So after finding the intersection points, again find out region code for intersected point. That means intersected points. Okay. Find out the region code for intersected points. Perform AND operation. Perform AND operation. Okay. If perform AND operation, if output is not equals to 0, that means non-zero output, then decision is then line is outside. Else, if output is 0, 0, 0, 0, then line segment is line segment with intersected point. That means the line segment constructed by intersected point. So better to write line segment of intersected point is inside of the clip window. Okay, so this is overall the algorithm of the Cohen-Sutherland line clipping algorithm technique. So first we have to find out the region code. If both the region code is 0, 0, that is totally inside, line is inside, and then exit. Okay. Otherwise, if both points are not 0, 0, Otherwise, perform the AND operation. If output of the AND operation is not equals to 0, that means line is outside exit. If it is 0, but then find out the intersection of line with the boundary.